All right, so this is number 9 on your OneNote. So this is a problem that you are going to see for the next, I think, few problems on your OneNote, and I'm going to show you how to do this first one. So I have put up here a little checklist of the things that you need to be doing in order to get this problem right, okay? So, calculating atomic mass. The first thing I have to do for this problem is read the question. A certain element has 2 naturally occurring isotopes. I know that an isotope is the same atom, meaning that they have the same number of protons with different number of neutrons. So, determine the atomic mass given the following data and identify the element. Okay, so I know that atomic mass is an average. So that means I'm going to have some sort of decimal. Atomic mass is different than the mass number, that is only protons and neutrons added. So atomic mass is going to be an average, it's going to be a decimal number, and that is what we're finding here. We're finding the average of the mass of whatever X atom. Okay, so my first step, I have to convert any percent abundances into decimals. Percent abundance into decimals. So I see I have 1% abundance here, and that is 75.53%. So I know that I can turn a percentage into a decimal by moving the decimal to the left 2 times. So to the left, and that is equal to 0.7553. Awesome. And I'm going to do the same thing for this bottom one. So 24.47, I'm going to move the decimal to the left, and that is equal to 0.2447. Okay, so I converted my percent abundances into decimals. Awesome. Check that off. Now I have to multiply the mass in AMU, meaning atomic mass units, of each isotope times the decimal percent abundance. Okay, so multiply the mass. So I see that for X35, I'm going to label it right here, my mass is 34.969 AMU. I have to multiply the mass times the decimal percent abundance. So times my decimal percent abundance times 0.7553. And I have to do the same for my other isotope. So that's X35. Now I'm going to do X37. So multiply the mass, 36.966 AMU, no naked numbers here, times my decimal percent abundance, which is 0.2447. All right, so I am multiplying it. So now I have to actually figure out what number this is. So let me get my handy dandy calculator. Let's see, I'll put it right here. Okay, so 34.969 times 0.7553 is equal to 26 point, and now I have to decide how many decimal places I want to keep. I'm going to go with the shortest number of decimal places. So I have 1, 2, 3, 4 decimal places here. I have 1, 2, 3 here. So I'm only going to write 3 decimal places. So 26.412. Awesome. So now I'm going to multiply the other one, 36.966 times 0.2447. And that is equal to 9 Same with how many decimal places? I have 1, 2, 3, 4 here. but I have 1, 2, 3 here. So I'm only going to write 3 decimal places. 0, 4, and that rounds up to 6. Great. So now I can check off this step. I've multiplied the mass by the decimal percent abundance for each of my isotopes. Last step, I'm almost done. I need to add each of the terms together. So I need to add this number and this number together. So back to my calculator. I'm going to put a little plus sign right here. 26.412 plus 9.046. And that is equal to 35.458. And I'm going to not leave any naked numbers. Atomic mass units is always the unit we're going to use when talking about mass of an atom. So, determine the atomic mass given the following data. Well, I've determined the mass, so that's my answer number 1. And then my second part of this question is to identify the element. So I can do that by pulling up a periodic table. 1 second here. So chlorine. Once you go into the periodic table and you look through all of the possible elements that could have a mass of 35 point something, you're going to find that chlorine has 35.452 atomic mass units. So this atom, these isotopes are likely chlorine isotopes. And that is how you do these questions.